Assalamualaikum, my name is Muhammad AZHAR bin Halim. This is the video of image processing project report for the title Image Segmentation using Nearest Neighbor Classifier. This project has been done with my partner Muhammad SAFWAN bin Muhammad Isa. From our title, Image Segmentation using Nearest Neighbor Classifier. What is Nearest Neighbor Classifier? Among the various methods of supervised statistical pattern recognition, the nearest neighbor rule achieves consistently high performance without a priori assumption about the distribution from which the training examples are drawn. It involves a training set of both positive and negative cases. A new sample is classified by calculating the distance to the nearest training case. The sign of that point then determines the classification of the sample. The k-nearest neighbor classifier extends this idea by taking the k-nearest point and assigning the sign of the majority. It is common to select k small and odd to break ties, typically 1, 3 or 5. Larger k value help reduce the effects of noisy point within the training dataset, and the choice of k is often performed through cross-validation. Why using k-nearest neighbor? The advantage k-nearest neighbor classifier is 1. Robust to noisy training data, especially if we use inverse square of weighted distance as a distance. 2. Effective if the training data is large. And last, the k-nearest neighbor classifier can be applied in a medical data mining. Medical data is an ever-growing source of information from hospital in form of patient record. This k-nearest neighbor algorithm increases the accuracy of such diagnosis. The algorithm can be used to enhance automated diagnosis, which include diagnosis multiple disease showing similar symptoms.
So I start off by reading an image ball.jpg. So this is the image that we are reading and trying to classify the ball in. So I initialize RCS size of X. Since the color image, we will have row and the column. Then I initialize the storage for every sample region. So I have 1, 2, 3, 4, 5, 6 sample region. 1 for red, black, blue, yellow, green and background. So in my class there is number of class will be 6 here, and I initialize matrix for sample region, which is basically all 0 here. So I start off by collecting the sample region. So I will using particular polygon ROI function which built-in MATLAB. So I'm trying to select sample region for every class. Once I have selected the sample region, I will display sample region using the loop. Now this one is RGB, convert the RGB image. So C form inbuilt function called match transformation color name to the color space coordinate system, and I convert this from the sRGB to lab. So sRGB is my standard computer monitor RGB values. This transformation I apply on the image X. So once I have calculate the lab value for the X image. Then I try to calculate the mean A and B value for the every ROI area that I have selected. So this one is A and B variable, and this one is matrix color marker will tell me the value mean of A and B in every class. So this one to find mean here, and this function to find out mean value of A and B. Once this done, it will try to classify each pixel using nearest neighbor rule. So we basically have each color marker how which has the A value and B value, which are average value for that particular ROI. Now we try to classify each pixel in the new image that we have by calculating the Euclidean distance between that pixel and the color marker. So the smaller distance will tell us that pixel which is most closely to match the particular color marker. For example, if the distance between a pixel and the red color marker is the smallest, then the pixel will be labeled a red pixel. This one color label start from 0 and number of classes -1. Right, we have label 1, 2, 3 till 5 here, a value and B value for each every pixel. Here I convert to a double to perform the mathematical operation on there, and then I have distance matrix to find out distance of every each pixel from the color map. So let's run this program and see the result. So you asking for the select sample region for red, so I just made polygon here. For black, blue, remember to double click to select it. Yellow, green, background, white. So my sample region are shown here. So this is my sample for red that I have clicked black, blue, yellow, green and background. And this how my segmented image looks like. So you can see the white spot are classified as background here because they are shining right here, and this is pretty close to what we want. And this scatter plot which is shown here to this pixel are categorized defined according to A and B spaces. Now we can apply this on another image. So let's run this also. So we have an image here for jellyfish. This is asking me to select the region for water. So for water is blue here. For the body, for the tentacle, I will pick up something over here. And this is how my segmented image looks like. So you can see here is pretty close to what we wanted.
And last, for the conclusion, the image segmentation result obtained with the modified nearest neighbor classifier are promising in respect of accuracy and computational efficiency. Taken together, they seem to be much better than pure one nearest neighbor pixel qualification. Nevertheless, the clustering method using histogram analysis are still faster. On the other hand, the nearest neighbor approach offers more accurate segmentation because the feature vector may constructed appropriately to the image specific. In the future, we intend to combine those two approaches to image segmentation in a hybrid algorithm.